In this video, we're going to be talking about the notice and wonder activity. So let's start by asking, what do you notice about this picture? You might say that even though it's complicated, it's just one large square. You might also say that it's made up of 4 smaller squares, 2 green squares, an orange square, and a, let's just say, complicated one for now. Another key observation would be that this sort of L shape appears in the picture, where 1 orange square and 2 green squares make the L. You might notice that the orange squares become smaller and smaller as you move up towards the top right corner. Similarly, the green squares also seem to be becoming smaller and smaller as you move up towards that corner. No matter how small the squares become, that L shape stays the same, which means that they're just scaled versions of one another. Another key observation is that the squares seem to be getting infinitely smaller on that top right square. And similarly, if I take a top right part and I zoom in, then I actually get the original image. And this is what's called a fractal. Finally, another few key observations are that the orange area is 1/3 the total area, while the green area is 2/3 the total area. So we can say that there's a 2-to-1 ratio between the area of green and the area of orange. So we've talked about what we've noticed, but with noticing comes wondering. So what do you wonder about this picture? What questions do you have about what's going on? You might ask, how many squares are there in total? What is the total area of green compared to orange? What does this represent in real life? Maybe something in nature? And what does this have to do with ratios? Could this picture be represented by a table or by a function? These are all really good questions. So to end this activity, let's look at just the first 2 L shapes. How do you know that the ratio between green and orange is 2-to-1? You might say that you could divide the region into 3 equal parts, and notice that only one of them is orange, and the rest are green. So to end this video, let's talk about some obstacles that might arise during the lesson and how to overcome them. So for example, if a student finds it difficult to identify the number of squares in the image, you might want to suggest that the student actually draw the picture themselves and ask them along the way, how many green squares are there and how many orange squares are there? And then maybe draw another part of the image and then ask again, draw again, and then ask again. Secondly, if a student finds it difficult to describe the relationship between green and orange squares in terms of a ratio, you could ask them, well, how are the green squares changing? And how are the orange squares changing? And are the number of green and orange squares increasing? And if so, by how much? Lastly, if a student finds it difficult to describe the pattern of increasing or decreasing squares, you could ask them, how are the sizes of the squares changing? What do you notice about the position of the squares?